All right, so we are finishing the the examples in the notes for 7.1. Problem number 5 says find the area of the region bounded by these two graphs. So these are functions of y. And it says use your calculator to draw the graph, set up the integral, and evaluate. I'm going to use my calculator on any of these that I can, just because it makes it a bit faster too. And these usually are calculator problems. So to graph these two equations, you need to solve them for y. So I did that here. And then I typed them into my y equals and just did zoom 6. So we can see that there's a clear right minus left here. So the equation on the right is the 6 minus y squared. And the equation, the line on the left, is the y plus 2. I'm going to leave them in terms of y because it's right minus left would be easier to do. And then what do I need for the right minus left? I need the y values of the intersection points. So onto your calculator, you can do second trace intersect. First curve is blue. Second curve is red. That's going to find this intersection point. I want to hop it down to the one in black. So that's the second curve I want. Enter, enter. So don't round this. This is negative, let me split screen here. I'm just going to write this down. This is negative 2.561553. That's going to be our A value. And then the B value at the top, intersect again. So I want it to be, it's on the blue line right now, so enter. And then, now I want it to be on red. And this one is going to be the value of B in the integral, so 1.56155528. Don't round those. Now you are allowed to do this on your, so let's define those more clearly. A is negative 2.561553, and B is 1.56155528. If you define those on your free response question, you're allowed to set up integral from A to B instead of writing out these numbers all the time. So we want the integral from A to B of the right minus the left. The right equation is the 6 minus y squared. And then we're subtracting the left equation, y plus 2. And because everything's in terms of y, there's a dy here. Now I can do this, I could do this algebraically, but again, just to speed things up, I would like to do it in the calculator. So I'm just going to clean it up a little bit. Negative y squared minus y, 6 minus 2 would be minus 4. So if we had to do this without a calc, we could. Otherwise I'm going to get to my home screen and then math 9. I do need to just type these numbers in. And again, I'm not rounding them at all. Now, if you rounded them, I don't know, would it make a difference to 3 decimal places? I think sometimes it does, so it's better to be more accurate here. And let's see, what did I have? Even though my equation is in terms of y, the calculator, you're still just typing in x because it's still using the same integration rules. It doesn't matter at this point whether they're x's or y's. All right. So I am getting, let's see. Now wait, something went wrong here. I'm getting negative 21.308. Let's see. Oh, it's not minus 4. It's plus. Seems weird that would be enough to make a difference, but I bet that sent my curve down. Let's see. Oh, there we go. I was going to say it can't be a negative area because this area right minus left, it looks like it would be positive. The x values on the right are greater than the x values on the left, so it seems like it's going to be a positive chunk of area. We don't get negative areas really for these. Okay, so let's see. Or I guess we could get negative areas. Another reason is because this isn't crossing the y-axis. Anyway, it's 11.682. Sorry, it's early. I'm babbling. This is 11.682. All right, let's look at the next problem. So problem number 6 says let R be the region bounded enclosed by the graphs x equals y squared and x equals negative 2y squared plus 1. Use your calculator to sketch the curves. Find the area of the region without a calculator. You can if you want to, but no, I'm not going to, just to save time. So, all right, let's get these in a form that we can plug them into our calculator. So if x equals y squared, then plus or minus radical x equals y. And then solving for this one, I would add 2y squared to the left, subtract x, divide by 2, and then plus or minus square root of 1 minus x all over 2. So let's graph this. So square root of x, negative square root of x, and then square root of fraction 1 minus x over 2. If you don't have the fraction option, put parentheses around 1 minus x and then divide by 2. And negative square root of fraction 1 minus x over 2. Zoom 6. Okay, so what is this region here? We can zoom in on this a bit. There we go. So we're looking at right minus left again. So we're going to leave our equations in terms of y's so that we don't have to do top minus bottom. And we want to find the intersection points again. So let's find second trace intersect. Now pay attention to your colors here, or the equation if you don't have colors. I want the intersection between blue and black. So blue, enter. And then let's hop it up to black. I'm just pressing up until it gets to the color I want. Enter, enter. I'm going to write this down. Now this would be this is the top value, so this is the B value. So let's let B is equal to 0.577353, and A will be the intersection between red and pink. So there's red, and there's pink. And that's negative 0.57735. All right, so find the area between. Again, it's just right minus left. There's no changeover where something different is on the right versus the left. So this is going, and the thing on the right, by the way, is the negative 2y squared plus 1. Okay, so this is the integral from A to B of right minus left. So negative 2y squared plus 1 minus y squared dy. Clean that up a little bit. You don't have to, I guess. I mean, we are just doing this in our calculator, so there's no real reason to clean it up. But if we were going to do this without a calculator, you definitely want to simplify it. Okay, and then, but if they're going to let you use a calculator to find intersection points, they wouldn't then have you do this without a calculator. So that's why I'm not bothering. So math 9, negative 0.57735, 0.5773503. They're probably both like that. I just noticed they're the same decimal. It's probably symmetric, but I'm just going to keep it as it is. And then negative 3x squared. Oh, whoa. That's in the wrong spot. Delete. Oh, that's annoying. Okay, let me type that in again. Negative 0.57735. There we go. Okay, negative 3x squared plus 1 dx. So this is about equal to 0.770. If you want to do it without a calc, I have that it comes out to negative 2 over 3 to the 3 halves plus 2 over square root of 3. All right, number 7. We're probably not going to get through all of the. Oh no, we're definitely not going to get through all of these in one video before office hours start. But we'll get through maybe this problem, and then I'll finish this video. So the area of the region between the curve y equals x squared and the line y equals 4 is divided into 2 equal portions by the line y equals c. Find the value of c. I've seen this version of this question in a few different places, so maybe we'll have something like this. This is non-calculator because we don't have an actual c, but we can sketch this graph. X squared is easy to sketch, right? And the line y equals 4 is easy to sketch. So this is the line y equals 4. I know the intersection points. When is x squared equal to 4? X squared is equal to 4 at plus or minus 2. So this is negative 2, and this is 2. And there's some line y equals c. So there's some horizontal line that we're supposed to put in here where the area on top is equal to the area on the bottom. So find the value of c. And did I place mine correctly? Absolutely not, but whatever. Okay, so there are probably a lot of ways you could set this up. You could find the area of the whole thing and cut it in half, or you could say that the area from, I don't know, the area from, let's see. Well, you could do things in terms of x, but it's supposed to be a y value. So I think I'm going to do this. The area from 0 to c is supposed to equal the area from c to 4. And if I do it that way, I would need everything to be in terms of y. So I think that might be easier to go horizontally, because otherwise these x coordinates are negative radical c and radical c, and I don't really want to do an area like that in terms of x. So how about we do that? Let's change everything to be in terms of y. So instead of y equals x squared, it's x equals plus or minus radical y. Okay, and then instead of, oh no, that's our only thing. And then we have y equals 4. Okay, and we have y equals c. So yeah, let's figure out what is the area from 0 to 4 of, let's see, what would this be in terms of y? We would have from right to left. This is radical y, and this is negative radical y, right? This is x equals, these are positive x values, these are negative x values. So if I'm going like this, what is this right minus left area all the way from 0 to 4? Let's do that first. So that area is radical y minus negative radical y dy. That would be the area of the whole thing. So you'd be integrating from 0 to 4 of 2 radical y dy. And what are we trying to figure out? Well, if we take half of that area, that's equal to the area from, I'm going to go 0 to c, or I could have done c to 4, but I think 0 to c sounds easier, of the same exact thing, 2 radical y dy. And this is kind of nice because 1/2 times 2 cancels out. So now we're doing the integral from 0 to 4 of radical y. So that becomes 2/3 y to the 3/2, evaluated from 0 to 4. And then this has an extra 2 out there, 2/3 y to the 3/2 from 0 to c. So on this side, we should get a number, right? So 2/3. So this is square root of 2, or square root of 4 is 2. 2 to the third is 8. 8 times 2/3 is 16/3, minus 0. And then over here, we would have 4/3, 2 times 2/3, times c to the 3/2, minus 0. Okay, so how about this? Times 3/4 to get that out of there. So c equals 3/2. How do I get rid of that? I raise 4 to the reciprocal, 4 to the 2/3, to solve for c. Find the value of c. I think I just did it. 4 to the 2/3, or a cube root of 16, or whatever you want to come up with. Yeah, so I did this in terms of y. If you wanted to do it in terms of x, the reason I wouldn't do that is because we were trying to find the value of y equals c. So it makes more sense to use y equals c instead of trying to figure out what x value makes this equal to c. I think doing it in terms of x would be much harder. Okay, I'm going to stop this video here. I've got office hours in a little bit, and I will make another video for the last chunk of problems.